Hello everyone. So here we'll have a live debugging session where we'll try to implement a network that we see here. So once I want to start debugging, I put the image on the right and I have my input values, input weights, the input a sigmoid function that I can use, some other constants and inputs, and now I need to implement the GRU function here. You learn about GRUs in homework 3. So I start with a basic implementation. Just by looking on the right, I start writing my equations here on the left. So da 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 da, and suppose I have written some basic equations based on my interpretation. Now I will try to run this code on the right, and I run this current file. Okay, I see there's a mismatch in dimensions. There are some shapes that are not matching. So let's see what can be my step 1 for this. So I see that the issue occurs in line number 16. So definitely that means that that equation is wrong and there is some shape mismatch in the multiplications there. So as step 1, I try to print all the shapes that I'm using in these equations. So again, I print all the shapes I have, then I rerun my code and I see, okay, the WZ shape is 2, 4, and you definitely cannot do a cross multiplication with HT1. So I again go and look on the equation on the right that, okay, HT1 and XT are actually being concatenated. But since I've written them separately, I will try to break up WZ instead and not concatenate HT1 and X1. So WZ needs to be broken into two halves for HT1 and X1, and looking at the shape, it means that I need to break it up. So I try to use the first two values and the last two values for each of these. This is just what I'm trying. Again, I run it. Again, there is an index out of bounds exception. So one way again here is to like keep on making changes, running your code, seeing the error, making changes, running your code, seeing the error. But that can take a lot of time. This is a very simplistic function that we see here, but most of the homeworks or anything that you'll have, they'll be calling a lot of functions internally. They'll be calling other places of code. It will not be as straightforward that you can just run your code and then go and look at all the errors. So a very good practice that I and a lot of other people I know are using breakpoints. So breakpoints allow you to debug your code completely on the fly, real-time calculations, real-time multiplications, and you don't really have to rerun your code again and again and again to see what is the correct implementation. Here I'm using PyCharm as the IDE. I generally use JetBrains IDEs because they have one for a lot of languages. We'll also later cover VS Code, where we'll show how to use these breakpoints in VS Code as well. So as you can see, I have put a breakpoint on 23, and now I run this code in debug mode. The breakpoint gets caught, the breakpoint gets hit, and we can now see that the code execution has stopped at that point. So the good thing about the breakpoint is that you can look at a lot of things correctly, currently, like what is the exact variable state, what are the expressions, and you can actually visualize them as well. Again, these might seem like very small arrays and very simple to look at arrays where you can simply just print all of it and see. But as you move forward, there'll be like many high dimensional arrays as well, and it is not always very easy to just print shapes or print everything and run. So yeah, I can also look at shapes, I can look at a lot of other bunch of things, and the best thing that I think is that you can execute your code on the fly. I think that is a very good utility that we have. So I go on the console and I again go and look at what is the shape like. Okay, it's 2,4. Then I look at some other shapes, and then I realize, okay, I need to split it up not on the first dimension but actually on the second dimension, because that is how it will be consumed into two different parts. So now I start to again experiment it. You can experiment it on the fly right there. You don't need to rerun your code, make changes, rerun your code. So this is significantly quicker. And then I can do an experiment. Okay, I take the first two elements in the second dimension and I might do a cross product, and whoa, it works. Then for the second part, I again take the next two the next two elements, and I multiply it by our input x, and whoa, again that works. We here are not focusing on the correctness of the equations as such. We are focusing more on how to make things work and how you can actually debug things on the fly. So again, as you can see that we are able to do our multiplications properly. So now that we have everything working, we can just concatenate. We can just like rewrite the complete equation, and you can see how we are building from small parts, and we are then going up, and we are like building our final equations. As you'll go into a lot of P1s, there can be some very big equations, and it's not always easy to write all of it at one and try to debug all parts of it. So it's advised that you start step by step and try to build it up from there. So, and yeah, everything works. So I replace my incorrect statement with the correct statement, and you can do it all at once instead of rerunning your code again. The next equation looks very similar, just that the weights are different. So we make those changes again, we stop, and we again run our debugging session to see now. Okay, another utility the debuggers offer is step-by-step execution. So there are two kinds of executions that you can do. One is step over and one is step into. So let's see what both of these are. Step over will basically help you to run the execution of that complete line in that place and head on directly to the next line if there is no error. And what step in does is it actually goes into your code and goes to the function call. As we can see here, it goes into the sigmoid call, and it gets the next breakpoint it hits it is as the sigmoid function there. So you can actually do your complete debugging in a live sense here, and you can follow the execution of the code step by step. So here we saw that at h hat it failed, and you can again see that okay, this equation is problematic, and you again go and look at the equations on the right and make necessary changes as you want. And you can have multiple breakpoints in place. Once you know that that the code works until point A or point B, you can remove the breakpoints from there, and you can continue debugging further. And yeah, we'll use a similar technique to debug this one as well. Again, I can go look at the shapes and get back to your debugging. You see that this thing is working correct. So you can break down your complete code into small equations, and instead of writing them separately and making your code look lengthy, you can do all your calculations right here in real time. And yep, once everything works, you replace your equation with the correct values, and yep, you can see how this significantly saves a lot of your time. And I personally also do not like to use a lot of print statements, since it makes the code more lengthy and hard to look at. So I generally just use these debuggers, and whenever you want, you can step into, you can step over, and you can look at all the shapes on the panel right there. So you don't really have to use a lot of these print statements, and yep, you can remove them. So yeah, these are different ways of debugging this, and once you think everything is correct, you can simply you can just disable all the debuggers and continue running your code in real time. And yeah, cool. So yeah, we can see that things work, and yep, everything is good. So this is similar to how most of your part 1 code would be, that you'll need to finish up functions, write equations, and make things work. So it's a good practice to use these debuggers and see where exactly your code is breaking, and then build those equations in smaller parts and then all the way up. Now let's look at some of the ways these debuggers can be useful in any of your part 2 homeworks. So suppose here I'm back to my MFCCs and I have some transcripts, and you can assume the MFCCs as X and the transcripts as Y, that is input versus labels. So here we simulate a dictionary structure again, that it would just mean that you're reading MFCCs from a file, and each of the files have the name as MFCC 001, transcript 001, and so on. And your final data object would consist of the X values and your Y values. Now you need to write your example dataset6 class and try to make it work. So let's see how we do that. So we go to our init function, we put our first debugger point there, we look at what it is asking for. We have like a lot of things to implement here. We look at what it exactly is asking for. It wants you to assign data to self. So you again go and start your debugging mode, and you can visualize all things that you want right there in the debug panel. My data dictionary, and I can see all the parts that I have. Another important thing that debuggers help you is to see that stack trace. So it might be that you do not know where the function is being called, where the input is exactly coming from, what exactly is causing the issue, where like it might be that the values that you're sending to the data to the function, those are wrong. So the stack traces on the left tell you where the call was made from, and you can see what the state of the variable, so that exact moment. And again, this is really helpful when you're trying to see where exactly your data is coming from, and maybe you're reading it wrong or something like that. And yeah, as you can see here, I can directly see the data object and make changes right there, instead of like running the code again and then coming back, running again, coming back. And yeah, once I think it's working, I restart my debugging session, and I can see I can just get all the file paths. So I'll again go and see what my state of the objects look like. So I need to pick the file paths, as we mentioned before, from the MFCC stick. So I can just try to, instead of writing it directly there and hoping that it works, I can experiment it right on the fly. Yep. So you have your files ready, file paths ready, and once you have your file paths ready, you can now start loading them into your arrays that you have. So once you know that a certain data breakpoint is working, you can just remove it so that it's faster, and then put it where you want it now to see whether it's working or not. And make use of the step over and step in lines generously, because I mean, you want your code flow to work, and it's comparatively more difficult, I believe, to debug things right on the Python notebook, because it's not very user friendly to do that. So in my what I generally do is I get a part of the data locally, and I write the classes here, I make sure everything is working. And again, my strategy is usually that, and I think it's a general strategy of a lot of people that I know, that you try to build your data objects right in the fly, and then once it works on here, you can just paste all your code in the actual Python notebook, and it will start working there. Let's have a look at how the stack traces is actually useful. So I have like written the complete class now here, and let's just have a look at the collate function. That maybe you realize that your stack trace comes out that the collate function is incorrect. So you can put a debugger again at the collate function, and then you can make a call and look at the stack trace that, okay, this is how the order of call is, and then you can realize, okay, this is where exactly it is failing. So debuggers are really helpful. That is all the point of this tutorial, and if you can make use of it, it's not just helpful for your course here. I think a lot of people, as you go ahead in life and you write code a lot of times in your life, debuggers are really helpful to break down large code bases. And it is basically, I think, the single most important tool that helps you to code faster and quicker. Yeah, so we saw how we can make use of debuggers for part 1 homeworks, make use of them for part 2 homeworks. Let's also, so I generally prefer JetBrains software, so that's why I did it in PyCharm, but a lot of people also use VS Code. So we can do the same thing in VS Code as well. So you open your files, you go and select your interpreter, whatever your interpreter is, and then we can simply put our breakpoints in place, as you can see in the next to the line numbers. And once you put all these breakpoints, you can start your debugging session, and you can see that the breakpoints get hit. And yeah, again, like the basic functionality for not just VS Code or PyCharm, it's like pretty much similar in a lot of the IDs. So yeah, I hope this recitation was useful for you, and you can refer this back whenever you're starting your homeworks and you're stuck on how to use these debuggers. Thank you.